This video we're going to do the inverse trig function derivatives, but before I go through all of them, because you know there's going to be 6, I want to do a quick review on what an inverse trig function really is. And I want you to recall that if f of x equals sine of x, then f inverse of x or arc sine of x or inverse sine of x. So when you look at the inverse, you're going to see it with these notations. You could see arc sine of x, or it'd be sine inverse of x. This is typically, you see this more on your calculator right here, but you could see it as arc sine also. So just a very quick brief review. If I had the sine of 30 degrees, I know is a 1/2, then the arc sine of 1/2 is going to be 30. If this is your input and this is your output, they are switched when you do the inverse because your points are switched. And the other thing is you could see it written like this: sine inverse of a half is going to equal 30 degrees if you're in degree mode. If it's in radians, you would get a decimal. So if I did tan of pi over 4 equals 1, if I wanted to rewrite that, I would be tan inverse of 1 is going to equal pi over 4. And here I've got the inverse of sine and the inverse of cosine in a little chart here to show you that now my x value is basically the value of the sine of that angle. They're backwards, if you will, and they're opposite, and that's what an inverse trig function is. Now, I'm going to kind of show you the two basic ones that we use a lot, and that's going to be the derivative of arctan and arcsine. I am going to show you the other 4, but these two we're going to use first. And the derivative of inverse tan of u is going to be 1 over 1 plus u squared du dx, or you can see it written this way. If my function is y equals inverse tan of u, then y prime is going to be 1 over 1 plus u squared times u prime, or you might see it where the u prime is right put in the numerator because that's what you end up doing every single time. So you would see either one. The derivative of arcsine is going to be 1 over this, so here's arcsine is 1 over the square root of 1 minus u squared times du dx, where the absolute value of u is less than 1. I don't mean to disregard that, but you don't have to look at that because I'm not going to be giving you anything like that, but it's nice to know. So here I have y is the inverse sine of u. For your function, y prime is going to be 1 over the square root of 1 minus u squared times u prime. And again, you could see the u prime on the top, so y prime would be u prime over the square root of 1 minus u squared. So you can see it either way. I have here listed all 6 actually. I just showed you the inverse tan and the inverse sine right here, but here are the other ones. You've got inverse cosine. Okay, so this looks very familiar or very similar to the arcsine, except it's negative. So we're going to write it this way, your derivative. And I know we've already done the card, but it's nice to have it. So y prime, in this case, is going to be u prime over, and it's going to be negative, excuse me, I should erase that. It's going to be negative u prime over radical 1 minus u squared. And then we've done these two already. Inverse cotan of u is going to be y prime is going to be u prime, and it's going to be negative all over 1 plus u squared. So you're going to have to memorize these, and if you'll look at what we just did is the derivative of arcsine, if you will, you're going to have to memorize that. That's not a problem. But then you have to do arc cosine, and it's the same thing but negative. Arctan, you have the derivative we talked about. Arc cotan, or cotan inverse, is going to be the same thing but negative. And of course it's going to work down here with secant, arc secant, and arc cosecant. These are a little bit different because you have absolute values that have to be greater than 1. But again, you really don't have to pay attention to this. So the derivative here is going to be u prime over the absolute value of u radical u squared minus 1. And arc cosecant is going to be y prime is going to be negative the same thing. So we've already put this on our derivative card in class, but I also wanted you to have it all in one place and so that you could refer back to it. So the remainder of this video is basically doing some practice problems, and I went too far. So let's practice a few. So keep out your derivatives because you're going to have to look at them until you have them memorized. So here's arctan. This is one of my favorites. So a prime of x, and arctan is, and this is u, is going to be 1 over 1 plus u squared. So I do 1 over 1 plus u squared. See how that works? Times the derivative of u, which is times 2. And this ends up being a prime of x is going to be 2 over 1 plus 4x squared. And please remember that you're squaring the 2 and the x. Arcsine, b prime of x. Like I said, keep it out. So it's going to be, and before I do this, I'm going to write this as 1/3 x. Because I know I've got to do the chain rule. So b prime of x is going to be 1 over the square root of, and this is our u again, 1 minus u squared, and u is x over 3 squared, so it's square root of it, times the derivative of the inside, which is going to be 1/3. So b prime of x is going to be 1 over 3 radical 1 minus x squared over 9. And you have to square the top and the bottom. I should make this a little bit deeper. So that's what that one would be. Let's look at 3. C prime of x. I again have arctan, and one of my favorites. So C prime of x is going to be, and this is our u, and you can also write it, this is x to the half, so that'll help you later. So C prime of x is going to be 1 over 1 plus u squared times the derivative of the inside, which is going to be the power rule, 1/2 x to the negative 1/2. And you know how this can all be rewritten, so I have C prime of x is going to equal 1. Now the 1 over 2, the 2 can go in the denominator, so it's going to be, okay, so you can say that's 2. This turns to a radical x because it's in the denominator, it's negative, okay, times, and then it's going to times 1 plus x, sorry. So let's see where everything went. Let's just review. This I know is going to be the square root of x squared is going to be x, so that's where that came from. Here's the 1, that came from there, that's not a problem. I took the 1 over 2, there's your 1 over 2. This was negative and it's the square root of x, so that came down in this spot. So that's where it all came from. Alright, now I have d of x is going to be inverse sine of e to the 4x. So I look at this, and this is my u. So d prime of x is going to be 1 over the radical of 1 minus u squared, so it's going to be e to the 4x squared, times the derivative of the inside, which is going to be this e to the 4x, so I'm going to rewrite it, times the derivative of the top, so e to the 4x times 4. Okay, so this is going to end up, and it looks not as bad, is I have 4 e to the 4x in the numerator, all over the square root of 1 minus e to the 8x. Okay, that's 4. And we got a few more here. 5, let's practice this one. Inverse secant, or arc secant if you will. Call this u. So get it out so you'll know what the derivative is. So e prime of x is going to be 1 over the absolute value of u, so it's 2x plus 1, times the square root of u squared, which is 2x plus 1 squared minus 1. So all I did was just plug it in that formula, and then I take the derivative of the inside, which is times 2. So I have e prime of x, okay, is going to be 2 over the absolute value of 2x plus 1 times, now this, I want you to see what I did here. This is going to be 2x plus 1 squared, and after I square it, I'm going to subtract 1. So that's really 4x squared. Let's just do it real quick. 4x squared. And then if I put it side by side, I'm going to have plus 4x plus 1, and then I'm going to subtract 1. So when I do this side by side, that's what I get. So when I do that, I see that these will cancel, so it's really the square root of 4x squared plus 4x. Okay? Which you're like, okay, that looks a little nicer, but then there's some more that we can do. And I want to show you some little algebra tricks. So we got e prime of x is going to equal, and if you will, see how this is a 2 here, and I'm wondering if I can simplify that. You can't with these two because it's a binomial, but I wondered if I could take something out, and I see that I can take a 4, the square, I can factor out a 4. So if I wrote this as 4 and I had x squared plus x, that 4 could come out of the radical as a 2. So this is what you end up with, 2 over the absolute value of 2x plus 1. And this came out of a 2, so I'm going to put the 2 out front, and I have the square root of x squared plus x. And then the 2's will cancel, so it's a little bit simplified, is 1 over the absolute value of 2x plus 1 times the square root of x squared plus x. And that's as far as you can go on that. Whoops, sorry. I didn't mean to do that. So this is our final answer. Okay. Inverse cotan. This is our u, and I'm going to write this because I know I'm going to need this later as x minus 1 raised to the half. So f prime of x is going to be, and just plug it in the formula, it's going to be negative 1 over 1 plus u squared, which is going to be radical x minus 1 squared, times the derivative of the inside, which is going to be the power rule, 1/2 x minus 1 to the negative 1/2. And then I look inside, and the derivative of x is 1, so we're done with the derivative. Now basically it's just algebra making this look nicer. So when I do this, I look at it and like, okay, this is cool. I've got this going on here, so you can do this part first if you need to. So I have negative 1 over 1 plus, now the square root of x minus 1 squared is going to be just x minus 1 times 1/2 x minus 1 to the negative 1/2. And if you'll see, these are gone. Thanks for playing. And I said, okay, what do I have left here then? So I have f prime of x is going to be a negative 1 over, the 2 is going to go down here. So now I can put the 2 down here in the denominator. So there's the 2. This is really the square root of x minus 1 squared, and it's negative, so I'm going to put it down here. Excuse me, the square root of x minus 1, I misspoke. And I've got the negative there, so I took care of everything. So there's our answer. Okay, there's 2 more here. I have e to the x, and I have inverse cosecant of e to the x. So I have e prime of x. Let's look at what we have here. I'm just going to plug it in the formula. 1 over the absolute value of u, which is e to the x, okay, times the square root of e to the x, or u squared, minus 1, times the derivative of the inside, which would just be e to the x. And I want to show you something, because a lot of kids don't think you can do this. Because this is an absolute value, you guys can cancel those out. So, because that's in the numerator. So I have e prime of x is going to be negative 1 all over the square root of e to the 2x, because it's power to the power, minus 1. I'm going to read some of this, because it's kind of long. Okay, so that's what it looks like. And our very last problem here is with arcsine, and I'm going to rewrite this as 3x to the negative 2, and this is my u. So f prime of x is going to be 1 over the square root of 1 minus u squared, so it's 3 over x squared squared. Okay. times the derivative of the inside, which is minus 6x to the negative 3, which is power rule. And I look at it, so I have f prime of x is going to be a negative 6 here on the top. The x to the negative 3 can go to the denominator. And then this I can write as 1 minus 9 over x to the 4th. Okay? Now, I want to show you a trick on this, so I want you to pay close attention to this. This is a radical of 1 minus this. And I look at it and say, I can do a common denominator, so I'm going to do a common denominator with this whole thing right here. So I'm going to rewrite all this. So I'm going to come over to the side. So the common denominator could be x to the 4th. This would be a 9. And this would be x to the 4th minus 9 all over x to the 4th. And you say, well, why did you do that? Because now look what I can do. If I take the square root of the whole thing, it's like taking the square root of the top over the square root of the bottom. Okay? And that's not going to help on the top so much, but I know the square root of x to the 4th is really x squared. And I have an x cubed out here. So this is what you end up having. See if I got here. F prime of x is going to be negative 6 over, and I'm going to go really slow. I have x cubed. This turns to, okay, watch what I have here, the square root of x to the 4th minus 9. I can't do that all over x squared now. And you see how this is multiplied? So this actually goes to a first power. So it is f prime of x is, well, I don't have to write f prime of x again. Let's just write the answer. It's going to be negative 6, okay, all over x times radical x to the 4th minus 9. So that's a little bit of algebra trick. So make sure that you follow through. And if you need to play the video again to see how I did that, but this would be our final answer. Okay, that concludes this video.